Okay, so here's the solution to Chapter 7 test. So the first problem was we had this curve, this particular curve, which intersected the y-axis at 6 and the x-axis at 3. And the equation was y equals 6 minus 2x. Now, what I asked you to do is to use the disk method around the y-axis. So the rectangle would look like this. It's horizontal, which means that you're going to integrate with respect to y. If you look at the volume for the disk method, it's going to be pi times the integral from c to d of capital R of y, quantity squared dy. So this is a vertical axis. So it's a disk method around a vertical axis. So that's the equation. So the limits go from y equals 0 to y equals 6. And we have to rewrite the equation in terms of x is a function of y instead of y is a function of x. So what I do is move this to the left and move this to the right, and then divide by 2, so you get x is equal to 3 minus y over 2, or you could say it's negative y over 2 plus 3. Okay, so that's the equation we're going to use, r of y. This is r of y. So now we just plug it in. So we get the volume is equal to pi times the integral from y equals 0 to y equals 6. And I'm going to use this form, 3 minus y over 2 squared dy. So first thing we have to do is multiply out this expression. So we'll get 3 times 3 is 9. Inner and outer, you'll get negative 3 halves y. So you get negative 3 halves plus negative 3 halves is negative 3. So you get negative 3, and then you get negative y over 2 squared, which is going to be positive y squared over 4 times dy. Okay, so now we're going to integrate. So they're all polynomials. So the integral of 9 dy is 9y. The integral of negative 3y is negative 3y squared over 2. And the integral of y squared is y cubed. And you're going to divide by 3. 3 times 4 is 12. And you're going to evaluate that between 0 and 6. So the 0 is just going to give you all zeros. So you got 9 times 6 minus 3 times 9 squared over 2 plus 9 cubed over 12. And of course, at the lower limit, you get 0. Why did I put 9 in there? I don't know. I know why I put 9 in there, because I had 9 there. I was like, that's not going to work out. 6. Okay, that'll work out. Okay, so you'll get 9 times 6 is 54. Here we have 36. Divided by 2 is 18. So this is 18 times 3, which is 54. And then the third one is going to be 6 cubed. So 6 times 6 times 6 is 196, I think. 36 times 6, 216. So we get 216 divided by 12. And if you take 216 divided by 12, I'm just going to get my calculator out. Okay, 216 divided by 12 is 18. So these cancel each other out. And so 216 over 12 is 18. And you get 18 pi, which is the correct solution. Now, as far as taking things off, I took major points off. If you used integrated with respect to x instead of with respect to y, if you didn't solve for x as a function of y instead of y as a function of x. Okay, next problem. Now, this is where I said a lot of people get it wrong, which you did, and a lot of people did, and the biggest problem is you forget what y equals 0 and what x equals 0. So x equals 0 is this line, not this line. This is the x-axis. The x-axis is y equals 0. So let's just write that out to emphasize this. X-axis is y equals 0, and the y-axis is x equals 0. So that's going to be one boundary. Then you're going to have this boundary, and then you're going to have this curved boundary. So the area is this part right here, and I asked to use the shell method around the y-axis. One of the reasons is so you wouldn't have to solve anything. You wouldn't have to change variables. So again, this thing, you stack the rectangles up in the x direction. So the limits are going to be from x equals 0 to x equals 2. So that's x equals 2. The other thing, if you did it the other way, you should have had two integrals. So I tried to be, if you made the wrong choice for area but did the calculations right, then I gave you more credit. So it depends on how many errors you made in that problem in terms of how much it took off. A lot of times there were compounded errors. Okay, so with the shell method, we're going to integrate with respect to x, and for rotating around the y-axis, p of x in this case is just x, and h of x is the difference in these two functions. So the upper function is 6 minus x, and the lower function is x squared. Y equals x squared. So this is y equals x squared. This is 6 minus x. So that's what h of x is going to be. And using the shell method around a vertical axis, that says volume is equal to 2 pi times the integral from a to b of p of x times h of x times dx. So in our case, the x limits are from 0 to 2. P of x is x. H of x is 6 minus x squared, and the whole thing multiplied by dx. So that's the integral. And the first thing we would do is we would just get rid of all these parentheses. So you'd have 6 minus x squared. And then you would multiply by x just to get 3 separate terms. So you get 6x minus x squared minus x cubed, whole thing times dx. So the integral of 6x is 6x squared over 2. The integral of x squared is x cubed over 3. The integral of x cubed is x to the 4th over 4. And you're going to evaluate that between 0 and 2. Now again, the lower limit is 0, so we don't have to, we'll get 0 from that. Also notice 6 divided by 2 is 3. So we'll get 3 times x squared minus x cubed over 3 minus x to the 4th over 4. And so 2 pi, here we have 3 times 4, it's 12. Here we'll have 8 thirds, 2 cubed is 8, and here we'll have 16 fourths. So we've got a common denominator of 12, because you've got 3 times 4 is 12. So here 12 times 12 is 144, so you get 144 over 12. Here multiply it by 4 in both numerator and denominator, so you get 32 over 12. Here we have to multiply by 3, so that's 3 times 16 is 48 over 12. So 144 minus 32 minus 48. $64. 140. Oh, the whole thing's 64. 64 over 12. So how do we simplify this thing? Well, we could do 128 pi over 12, and both the numerator and the denominator are divisible by 4. So 128 divided by 4 is 32. So we get 32 pi over 3. That's the answer. Problem number 3, I gave you some slack, and I see that a lot of you must have talked about the previous problem during the when you took the problems, because you got problem 3 right in this case, but you got problem 2 wrong, and so that's that's why we did it in parts instead of letting you take the whole thing or having a break in between. So I guess that was the right thing to do. Okay, so the only difference here is instead of rotating around the y-axis, you're going to rotate around a vertical line of x equals 8. And so the radius now, with the previous problem, p of x was x. In this case, p of x equals 8 minus x. And this problem's worth 10 points. The first 2 problems were 30 each, so it wasn't worth a huge amount. But you're going to get 2 pi times the integral from 0 to 2, because the area here is still from 0 to 2. And instead of p of x being x, it's 8 minus x. Now h of x is the same, so you get 6 minus x squared, and the whole thing times dx. And that's all I was looking for. I was basically looking for you to do that. Now, because I messed up on the question, because I changed the problem from a previous year, I changed the wording, was kind of confusing, so I didn't really take anything off if you didn't draw the arrow, because there's only one radius. There's no inside or outside radius. There's just the radius, which is p of x. I think most people who knew what they were doing realized that, because they got the answer right. But I apologize for that. But I didn't take anything off for it. So that's it. Okay, next one. I guess most of you guys did pretty good on this one. I had these 3 lines. So we had a line like that, and a line like this. So this line, which had the highest negative slope, would be y equals negative 4x plus 19. This one, which also has a negative slope, but it's not as big, would be y equals negative 1/3 x plus 8. That's this one here. That's this one here. And then you've got the one that has a positive slope, which is this. Oh, no, it's not, I'm pointing the wrong place. Okay, that goes here because these both had negative slopes, but this one has a higher negative slope. And then this one here has a positive slope, so that's the last one. 3/2 x minus 3. Now I asked you first thing to do is to find the points of intersection analytically. So let's say the red and the blue. So that's at this point. You had the answers because the graph was to scale. So this was 3,7. This point was 6, 1, 2, 3, 4, 5, 6. Is that right? 1, 2, 3, 4, 5, 6. Yeah, this was 6, 6. And this one was 1, 2, 3, 4, 1, 2, 3. So that was 4, 3. Okay, so we're going to do negative 4x plus 19, which is the red curve. Blue curve is negative 1/3 x plus 8. So the first thing I would do is multiply everything by 3. So I get negative 12x plus 3 times that is 57. Then I get negative x plus 24. Let's go to the other side, become a negative 11x, because you'd add 1 to both sides. And then this would go to the other side, and it would be 33, negative 33, because that's negative 57. So this goes to there, becomes positive. This goes there, becomes negative. Divide both sides by negative 11, you get x equals 3. And then we don't really need y because we're going to integrate with respect to x. But if we plug that back in here, let's say you'd have negative 4 times 3 plus 19, which would be negative 12 plus 19, which would be 7, which is that. Okay, so that's the first one. Second one is the blue and the green. So that's going to be 3/2 x minus 3 is equal to negative 1/3 x plus 8 multiplied by 6 to get rid of the two denominators. So you're going to get, so if you multiply by, well actually what we want to get is 6ths. Okay, so we're going to multiply this by 3 in both the numerator and the denominator. Doing this right? No, I'm just going to multiply by 6. So if I do that, 6 divided by 2 is 3. 3 times 3 is 9. This times 6 is 18. This times 6 would be, you'd have 6 divided by 3, which is 2. And 6 times that is 48. Okay, bring that to the side. You get 9 plus 2 is 11. Take that to the other side. It becomes positive 18. That's 66. Divide both sides by 11, you get 6, which agrees with that. And then you can plug that into either one of these equations. I'm going to use the green one. So you get 3/2 times 6 minus 3. So that's 18 divided by 2, which is 9. 9 minus 3, which is 6. So that's 6, 6. So that's the second point. And then the third one is you're going to set the red and the green equal to each other. So you get negative 4x plus 19 is equal to 3/2 x minus 3. Okay, multiply everything by 2. To get rid of any fractions. And then let's move this to the side. It becomes negative 11x. And move that to the other side. And that becomes negative 38 minus 6 is negative 44. Divide by negative 11, you get x equals 4, which agrees with what I have. And then you could use either equation. So I'm going to use this one. 3/2 times 4 minus 3. So that's 12 divided by 2, which is 6, which is 3, 4, 3. Okay, so those are the limits. Now, to do so these, both cases used vertical rectangles. So we use the shell method around the y-axis or the washer method around the x-axis. So, and all I was asking for was the equations. So you've got, this is the, let's say the washer around the x-axis. So that's going here around the x-axis. And the equation for that is the volume is equal to pi times the integral from a to b of capital R of x squared minus small r of x squared, whole thing times dx. And as you see, with these two rectangles, I've got to have two limits, from 3 to 4 and from 4 to 6, because the upper curve is always the same, but the bottom curve changes. So our first one, from 3 to 4, and the upper curve is the blue curve, so it's negative 1/3 x plus 8 quantity squared, and then I subtract the bottom curve, which is going to be the red curve, which is negative 4x plus 19 squared, whole thing times dx. And then I have my second integral, which goes from 4 to 6. So where I've left off here, I start there. And the upper curve is still this negative 1/3 x plus 8. And my lower curve has changed. It's now this green curve, which is the only one that has a positive slope. And times dx. So that's it. Now for the shell around the y-axis, you have the same orientation of the rectangles because the shell goes this way. So we're going to still be, since they're vertically arranged rectangles, we're going to integrate with respect to x. We're going to have the same limits. We're going to have the same curves, but instead of squaring them, we're going to not square them. So if you look at the shell method around a vertical axis, it's 2 pi times the integral from a to b of p of x times h of x times dx. Now, because we're doing it around the y-axis, p of x is x. So that's for this. And h of x is dependent upon which one of those rectangles. But remember, I think most people did remember, once you've got one of the integrals, you can get the other one easily. So the thing you change is pi goes to 2 pi. We still integrate from 3 to 4. We still have the upper curve the same, but we don't square it. And you subtract the lower curve, meaning closer to the x-axis. You don't square it. We multiply by p of x, which is x, and we multiply dx on the other side. And then the second integral is the integral from 4 to 6 x, and again we go over here. So you get negative 1/3 x plus 8 minus 3/2 x minus 3, and the whole thing times dx. So that was the second part, or the first part, whichever one I asked for. I'm not sure which one I asked for first. Okay, next problem is number 5, which is the area problem. So most people got this right. The first thing you had to do was find the limits. Again, you know what they are because you look at the graph. It's 0 and 4, but how do you do that? Well, if you have two curves no matter what curve type they are, and they intersect, you just set the two equations equal to each other. You know, what values of x give you the point where the y value is the same. So we just set those equal, and we can then move everything to one side. So this negative goes to the left-hand side, becomes positive. This, we've got positive 4 on both sides, so those are going to cancel out, because if you subtract 4 from both sides, it goes to 0. I'd multiply by -1 because I just don't like negatives in front of x squared, but you could factor out a negative x if you wanted to. Okay, so this becomes positive, this becomes negative. Factor out an x. So the two solutions are x equals 0 and x minus 4 equals 0, or x equals 4. And that's what we knew the answer was anyway. So those are the limits. And remember, the area is the integral from a to b of g of x minus f of x dx, where g of x is a curve that's on top, and meaning the more positive, and in this case that is going to be the curved one, which is negative x squared plus 3x plus 4, and the lesser curve with lesser value is the other one, negative x plus 4. So we found the points of intersection, 0 to 4. We have negative x squared plus 3x plus 4. So that's g of x. We subtract f of x. And you should end up with something that looks like this, one of these two, because here we're subtracting them, here we set them equal to each other. So it's equivalent, same equivalent situation. So what happens is these 4's, this 4, positive 4 will get canceled out with that negative 4. So you'll end up with negative x squared plus 3x plus 1 more x plus 4x, and that times dx. So it's just a polynomial integration. So the integral of x squared is x cubed over 3. The integral of 4x is 4x squared over 2, and we're going to evaluate that between 0 and 4. Again, with the lower limit being 0, we know that the polynomial is going to be 0. So we just have to evaluate it at the upper limit in this case. So we get 4 cubed over 3 plus 4 times 4 squared over 2. But 4 cubed and 4 times 4 squared is the same thing. It's going to be 64. So you get negative 64 thirds plus 64 halves. And if we find a common denominator, which is 6, you're going to multiply this by 2 in the numerator and the denominator. So you get negative 128 over 6. And here we get times 3, which is going to be 3, that's 180 plus 12, 192. 192 minus 128 is 64, so you get 64 over 6, which simplifies down to 32 over 3. And there's your answer. Okay, and then the extra credit. So this one, you did have to integrate with respect to y. So you had this curve, and you had this curve kind of like that. This was y equals 2. I didn't ask you to solve for it analytically, but you could if you wanted to. So I said to use the shell method around the x-axis. So the shell method is going to be this horizontal rectangle. Again, because if I did it the other way, I'd have to have 2 integrals. So it was easier to do it this way. So the limits are going to be from y equals 0 to y equals 2. Because I'm integrating with respect to y, I have to rewrite the two equations in terms of x is a function of y. So you'd square both sides and then solve for x. So you get x equals y squared plus 1. And that's this curve. And the other one is y is equal to negative x over 2 plus 9/2. So again, I'd multiply everything by 2. Get rid of the fractions. If I move the negative x to the other side, it becomes positive x. If I move the 2y to the other side, it becomes negative 2y. So those are my two equations. Now, because I'm using the shell method, that's nice because I don't have to square stuff out. So the volume is going to be equal to 2 pi. So that's what it is for the shell method. I'm going to integrate from c to d. That's the y limits. I have p of y times h of y times dy. Shell method around a horizontal axis. And when the horizontal axis is the x-axis, p of y is just y. And h of y is this distance from here to here. So the upper part, the more positive y part, is the linear function. And the more negative part is the quadratic function in terms of y. So that's h of y. So our final integral is 2 pi, the integral from y equals 0 to y equals 2 of negative, so you get y, p of y is y. Let's put that in brackets, square brackets, so you get y times negative 2y plus 9 minus y squared plus 1, whole thing times dy. So first thing we do is we're just going to simplify what's inside square brackets. So you've got, I'll put the highest order term first. So you get negative y squared. Then you've got negative 2y. And then you've got 9 minus 1, which is 8 times dy. And finally, you multiply the y, the p of y times everything. So you get negative y cubed minus 2y squared plus 8y. That whole thing in parentheses times dy. So I'm just making sure I did that right before I integrate. Okay, so that looks right. Okay, so now integrate. So the integral of y cubed is y to the 4th over 4. The integral of y squared is y cubed over 3. And the integral of y is y squared over 2. We're going to evaluate that between 0 and 2. So again, one of the lower limits is 0, so we're going to get 0 when we plug that in. So all we have to do is evaluate it at the upper limit. So you get negative 2 to the 4th over 4. Subtract 2 times 2 cubed over 3 and add, well, you notice 8 divided by 2 is 4. So we get 4 times 2 squared. So that's 2 pi times, okay. So 2 squared is 4. So we're left with, out of the 2 to the 4th power, 2 squared gets canceled out there. So we get 2 squared, which is 4. Then we have 2 cubed, which is 8, times 2, which is 16. So we get negative 16 thirds. And then we get 2 times 2, which is 4, times 4, which is 16. Now let's just go ahead and, well, we could take 16 minus 4 is 12. So you get 12 minus 16 thirds. and then we'll make it in terms of thirds. So we get 12 is 36 thirds. Subtract 16 thirds. So you get 2 pi times 20 thirds. So 36 minus 16 is 20. 20 times 2 is 40, so we get 40 pi divided by 3, which is the right answer. From a point standpoint, the first 2 problems are worth 30 points. The third problem is worth 10 points. The fourth problem is worth 30 points. Fifth problem is worth 25 points, and the extra credit was worth 10 points. So the maximum you can get, I think, on the test was 106, 105, something like that. And I did curve yours a little bit more than the Governor School students, just because I know it is more difficult to not be able to ask me questions in person. So I did give you a little break there. Okay, so that's it.